In this lesson, we are going to talk about resilience, even though this isn't a topic that might be too related with a REST API, it's still important when we are integrating with other applications. In our example, we are using the GitHub REST API, which is typically reliable, but it's not guaranteed that we won't run into problems. And this is what resilience tries to solve. By introducing a resilience pipeline into our HTTP clients, we're going to improve the reliability of our third-party API calls and increasing the likelihood that they succeed. Now, the standard library for implementing resilience in .NET applications has been Polly for a long time, but recently we've gotten some improvements to this library by Microsoft adding some resilience packages that integrate directly with Polly and allow us to define so-called resilience pipelines. These pipelines also work with dependency injection, and this is a very broad topic, and I'm going to leave some useful resources available right under this video if you want to do some more research. What I'm going to focus on in this lesson is configuring a resilience pipeline for our HTTP clients. Inside of my dependency injection setup, I'm configuring two HTTP clients. One is a standard name client called GitHub, and then there is the Refit HTTP client, which we added in our previous lesson. Now, if you wanted to add resilience to these libraries, you could install Polly manually, create a delegating handler implementation, and implement a custom resilience pipeline. However, this isn't the most efficient approach, and I'll show you a library that you can use to achieve similar results. So let me look for resilience, and right out of the box, you can see a couple of Polly libraries coming out as the first results. Now, if you take a look at Polly extensions HTTP, which is the one that was commonly used for adding resilience to HTTP clients, you can see a message that says that this is deprecated and that you should instead use Microsoft Extensions HTTP Resilience. And this is the library that I'm talking about. You can use it from both .NET 8 and .NET 9. There is also Microsoft Extensions Resilience, which is the more generic approach, but I want to focus on the HTTP Resilience library. So I'm going to install the latest version, and then I can close this down. And now let me show you what we can do here. Let's say I want to add a resilience pipeline to my GitHub API definition. There is now a new method called add resilience handler, and this is added by the library that we just installed and is going to allow me to define my custom resilience pipeline. I think this is best explained with an example, so I'm going to drop in an implementation and we can discuss what it does. So I'm calling add resilience handler and I'm giving a name to this resilience pipeline. This is now the new way of calling policies as they were defined in Polly for many versions. This has been replaced by the resilience pipeline. So you get access to a resilience pipeline builder, and this specific one uses the HTTP response message as the result type. And now I can just call some standard methods that are available in Polly. For example, I can add a timeout resilience strategy, I can add a retry resilience strategy, I can add a circuit breaker, and I can include another timeout. The order in which you define these strategies is important because that is how they are going to execute in the resilience pipeline. And what we are achieving here is essentially having a global timeout of, let's say, 5 seconds. Then we have a retry strategy that's going to function within our global timeout. So all of our retries will have to complete in at most 5 seconds total. Then we have a circuit breaker after the retry strategy, and finally a timeout in the end, which is going to apply to an individual request. This also includes any retries, so at most our original API request and any retries have to complete in 1 second. Now, the specific of how all of these strategies work are a bit outside of the scope of this course, but I will leave some useful documentation links available right under this video if you want to learn more. So with this resilience pipeline defined, when we send requests using our Refit GitHub API, all of our requests are going to run through the pipeline, and if we run into any exceptions, our resilience strategies are going to kick in and try to compensate for this by executing a retry, but also making sure that the downstream service continues to be available by introducing a circuit breaker. If the downstream service fails for too many subsequent requests, then the circuit breaker is going to kick in and we're not even going to send a request to the external service. Now, another thing you can do, which is also made available with this library, is introduce a global resilience handler. You can say builder services add HTTP client. Then I can chain a call to configure HTTP client defaults, and here I can access the builder and say add standard hedging handler, which is going to send multiple API requests in hopes that one of them is going to complete first. Or you can add the standard resilience handler, which is going to do something very similar to what I defined here. Now, a big problem that you will run into with the current API surface, and this might change in the future, is that this resilience handler can't be overridden. So if you configure a global resilience pipeline, the custom one that you add to your individual clients will not work. So what you can do is call an extension method that was added in the most recent version of this library, and the API surface is remove all resilience handlers. Now this is still an experimental API at the time of recording this video, so I will have to add some pragma warnings to make this work, or an alternative that we could try to get rid of this is simply use the implementation that's defined here. So let's say this is the approach I want to take. I will add a new class inside of my extensions folder that's going to pretty much implement this identical method. And now I should be able to reference my new method and get rid of the pragma comments. So let me go to our previous state of the code, and then when calling remove all resilience handlers, I want to make sure that I'm calling the one that I defined. So because there's now a naming conflict with my custom implementation, I'll have to use a different name. So for example, I can use internal remove all resilience handlers. And let's call our new API here. And when the new one becomes stable, then you can continue using it. Now, what about the standard resilience handler? What does it do? Well, if I go into the definition for this method and I break down this line of code into multiple lines, you should be able to see the individual resilience policies that are being configured here. So let me adjust this. And now you can see what's going on. We have a rate limiter as the first policy, then a timeout policy, a retry policy, a circuit breaker policy, and a timeout policy. So very similar to the custom one that I was defining. And I was essentially basing my custom implementation on the standard one that we have here. And this standard resilience strategy is something that Microsoft recommends from many years of experience of running world-scale cloud services. So this is what you get with the standard resilience handler. Let me close this down, and I'm going to comment out this implementation here because I don't want to define my custom pipeline, and I'm going to also omit the call to removing all resilience handlers, and I will rely on the standard resilience handler that I configured globally. Now, in order for us to simulate a failure when talking with the GitHub REST API, I'm going to add a custom delegating handler that's going to introduce a delay to all of my API requests. So let me add this in the services folder, and I will call this the delay handler. This is what the implementation of the delay handler will look like. I'm just going to implement the delegating handler base class, and I will override the send async method to introduce a fixed delay of 10 seconds to each API request. Now I will need to register this with dependency injection, so I'll say builder services add transient, specify my custom delay handler, and now I need to include this as an additional HTTP message handler when configuring my Refit API client. So now I should be able to start the application, and my delegating handler will work when sending requests using the iGitHub API client. So let's send a request to fetch the user's profile, and you will see that this is going to take a while because of the fixed delay that we introduced before each API request. Now eventually this is going to fail because we are going to run into a cancellation, and then our retry is going to kick in, trying to communicate with the REST API again, but eventually we're going to exhaust all of our retry attempts and we're going to get a task cancellation. After a bit more time, we're going to run into the total request timeout, which is 30 seconds, and we're going to get a response back in Postman. So we're getting an internal server error. So let's jump into the Aspire dashboard, and we'll take a look at the last few structured logs where you can see that we are sending a request to the GitHub API to attempt to fetch the currently authenticated user. So this is our first request. This is going to fail, and then we're going to get a retry, which is represented by this structured log here. So this is just a quick demo of how the standard resilience handler works, and after 30 seconds, which is the total request timeout, is going to fail the API request, and we get back a 500 internal server error. So in this lesson, I demonstrated how you can introduce a standard resilience handler to your HTTP clients to make your external API requests more likely to succeed. Resilience is a very broad topic, and the example I used here was very focused to demonstrate a specific case. Now, another important topic that we have to discuss when talking about REST APIs is rate limiting. So let's jump into our next lesson where I'm going to show you how to implement this.